The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
A solution of sucrose in water is 28.0% sucrose by mass and has a density of 1.118 grams per mil. What mass of sucrose in grams is contained in 3.50 liters of solution? I want to highlight that I've written all my knowns down in a column here. Very helpful. It gets rid of all the excess text. And I have not put down the complete units here. For example, a solution of sucrose in water is 28.0% sucrose by mass. Okay, that's good to know. That means that if I take any sort of amount of this solution, whether it's a bucket or a tower full or a little cup full, it's always 28.0% by mass. That means that if I just take arbitrarily 100 grams of solution, maybe that's the mass of my solution in the cup, arbitrarily, then 28 of those grams should be sucrose. I can extract that information straight from this number. And similarly, the density is not complete. The solution has a density of 1.118 grams per mil. So this should be grams of solution divided by mil of solution. Okay. Now we're looking for the mass of sucrose in grams contained in this amount of solution. Alright, so we see that this is a conversion because it's a ratio of two things, and this is a conversion, a ratio of two things. But this is not. This says, use me. Okay, so we'll use you since that's what you tell me to do. Number? Okay. Here we go. So we're going to start with our 3.50 liters of solution, and we're going to convert this number using our conversion factors to our answer. Follow your units and you can't go wrong. Okay. How do we follow our units? I'm at liters of solution, so I need to cancel out liters of solution somehow. Now, I don't see liters of solution anywhere. Here's liters of solution, but this is what we're using. But I see something close. I see that this is milliliters of solution, so I can just simply convert this number into mils of solution. Okay, so I need to cancel my liters of solution. How do I go from liters to milliliters? I know that there are 1,000, remember that this is exponential notation, 1,000 mils per 1 liter. This gives me 3,500 mils solution. Okay, now I can take that number, 3,500 mils solution, and use this conversion factor, the density, to go from my mils of solution so that my units cancel. And I'm going to put grams up top because I'm using this conversion factor. Put the numbers in their correct spots. Be sure to put the units with their right numbers. No? Good. So now I'm at grams of solution. But the question wanted me to get grams of sucrose. So how do I go from grams of solution, look at that, grams of solution to grams of sucrose? So I'm going to use that ratio. 100 grams solution. I have to put gram solution on the bottom so that gram solutions cancel. I'm going to put 28 grams of sucrose up top. And then you're going to punch in those numbers, multiply this number with this number with this number, and then divide by every number on the bottom. Alrighty. Once you do that, the correct answer is 1.1 times 10 to the third grams of sucrose. Okay. Yeah, that should do it. Alright, so just to review, something I suggested was to follow your units, and I noticed that a lot of students have trouble with this, If you follow your units, you're almost guaranteed to get the right answer. And you don't even have to think about it, really. We started out with liters of solution. We started with that number that's not a ratio. It was just a number that was just solidly given without being a ratio. We converted that to mils because we needed mils of solution in order to use this conversion factor. So there it is. And then we killed the grams of solution by using the last conversion factor. You might not always have to use all the numbers given in the problem, so be careful. Your professor might be trying to throw you off. But be sure to follow your units and you're guaranteed to get the correct answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.